This lesson is on the mathematical development of various interest rate formulas. So let us start with simple interest. Now, as its name implies, simple interest is interest that is based only on the original principal. And that is regardless of how long the original principal is in the account. If it's in the account for a year, 2 years, whatever, the interest is only based on the original principal. So the formula is going to look something like this, where interest is simply equal to the principal times the interest rate as a decimal. Now, since the interest rate is actually given as an interest rate per year, you should add the time if this goes in excess of a year. So the full formula is I is equal to PRT, where T is in years and the interest rate is interest rate per year or per annum, as it is referred to. So what then is compound interest? Compound interest is money earned on the money deposited, in other words, the original principal, plus any previous interest. So let me make that clear. It's compound interest is money earned on the money deposited plus any previous interest. So you might think of this as the balance in your account is equal to your principal plus any interest income that you've earned. And as we learned when we were talking about simple interest, the interest income can be represented as the principal times the interest rate per year, or B is equal to P plus PR. So we can take this a step further by mathematically factoring out the P and coming up with B is equal to P, parentheses 1 plus R, parentheses. Now again, the interest rate is interest rate per year, so we can add the T for the time in years, because in 1 year we would have P times 1 plus R, but the second year we would have an additional 1 plus R. So basically you end up with B is equal to P, parentheses 1 plus R, parentheses, raised to the T power. So whereas T is the number of time, is the time in years. Now, for that would be assuming we had compound interest that was compounded annually. What if we have interest that's compounded in something less than a year? For example, every 6 months, or every month, or every week, or every day. Well, then we have to add in this term N, which is the number of times per year that the interest is compounded. Okay? The number of times per year that it is compounded. For example, if the interest rate were compounded every month, N would equal 12. And therefore the interest rate is the interest rate per year divided by 12. So every month you'd get 1/12 of that interest rate, okay? And similarly, the exponent, instead of just being T, is now going to be NT, because it's the number of times per year times the number of years, okay? So our full formula for compound interest is equal to B is equal to P, parentheses 1 plus R over N, parentheses, raised to the NT power. So let's take compound interest a step further, and let's say, what if we had smaller and smaller intervals of time where the interest is compounded to the point where the interest is compounded continuously, okay? So it'd be an infinitesimal amount of time that the interest rate would be compounded, and we would make that infinitesimal time smaller and smaller and smaller to the point where we would have continuous compounding. So as I said, continuous compounding implies that the number of times it's compounded per year is going to approach infinity, or a very, very large number. So if we go back to our compounding formula, we have the same formula we had before, but now we have the term n going to get very, very, very large for continuous compounding. So now if we do some mathematical manipulations, we can see that r over n is the same thing as 1 over n over r. Okay, we simply take the reciprocal of r over n. So it's 1 over n over r, and that's the same thing as r over n. Now, we have this term n over r. It'd be nice if we could get that same term up in the exponent. Well, we can if we say n over r times r. Well, n over r times r is simply n, which we started out with. So now we have the balance is equal to the principal, and the quantity in parentheses is 1 plus 1 over n over r, raised to the n over r times rt power. So now let's look closely at that portion of the formula that is shown in red here, okay? We could simplify that by saying that it's of the same form as 1 plus 1 over x, that whole quantity raised to the x power. Now remember, with continuous compounding, we're implying that n is going to get very, very large. Well, in our general form here of 1 plus 1 over x raised to the x would have to get very, very large for the same in the same format. So basically what we're talking about with continuous compounding is we're talking about the limit as x approaches infinity of the quantity 1 plus 1 over x, that quantity raised to the x power. So what exactly does that limit equal to? Well, let's take a look at this from a graphing perspective. Let's use the expression, the quantity 1 plus 1 over x raised to the x, set it equal to y, and graph it. Well, our graph is shown here. Now, we're only concerned with values of x that are positive, okay? We're not concerned with negative time in this case. And you'll notice that as x is positive and as x gets bigger, we appear to be asymptotic to some value between 2 and 3. As you can see here, the graph is flattening out and almost coming perfectly flat. Well, if we look at that really closely, we can see that the asymptote appears to be at 2.718 ... So it's some value approximately at 2.718. Well, what exactly is 2.718? That mathematically is the constant E, okay? Remember we have pi is 3.1415. Well, we also have another mathematical constant E, which is 2.718. So now, for continuous compounding, I can substitute and take that term that's all in red. Remember, I took the limit of that as n got very, very, very large, and I realized that the limit approaches E. So therefore, our formula now becomes, for continuous compounding, that the balance in your account is equal to your original principal times E raised to the RT power. Remember, E is that constant, 2.718. R is still your interest rate per year, T is your time in years, P is your original principal. So that is how we go basically from simple interest to compound interest to continuous compounding.